So today we'll see how to solve linear equations with matrix. So I have two sets of linear equations in two variables x and y. So that is 2x plus 3y is equal to 10, x plus 4y equal to 12. Before we see how to solve these two equations with matrix, let's use the traditional way of solving it. Let me change the color of the pen. So generally what we do is we will probably do 2x plus 3y equal to 10, multiply the second equation with 2, so 2x plus 8y is equal to 24. Then you will probably subtract the first equation with the second equation, then you get minus 5y equal to minus 14, y equal to minus 14 by 5, plus 14 by 5. Now what you do then is substitute the value of y in the first equation. So you have 2x plus 3 times 14 by 5 is 42 by 5 is equal to 10. Let's divide the equation by 2. So you have x plus 21 by 5 is equal to 5. Then you have x is equal to 5 minus 21 by 5, x is equal to 4 by 5, right? So this is how you generally solve the set of linear equations. But today let's see how to solve this with matrices. The reason I'm saying this is because matrices are very useful when it comes to handling arrays in Python, whether be it NumPy or whether be it data frames in pandas, so on and so forth. It's going to be very useful going forward when you're doing a lot of data science projects. So today I'm going to talk about how to solve this using inverse matrices. This is only useful when your matrices are inversible. I'll make another video I'll make another video where you have a matrix which is not inversible and what you do in that case to solve the set of linear equations, right? So for now, let me change the color of the pen. Let's represent the set of equations in a matrix form. So the way to do it is you have 2. Let's write down all the coefficients of the variables. So 2, 3, 1 and 4. So this is your coefficient matrix. Let's write the variable matrix x and y. This is equal to your constants 10 and 12. So what this is nothing but your a, x and b, right? I can possibly say x is equal to a inverse b, correct? So if you can find out what your a inverse is and multiply it with b, you will arrive at the values of your variables. So the trick here is to calculate your a inverse. Let's change the color of the pen. So let me just put a box out here. So a inverse is nothing but 1 by determinant of a times a matrix. What goes into this matrix is some of the values from your coefficient matrix or your a. So let's say your a is actually equal to a, b, c and d, right? What goes into this would be d, a. So basically I've inverted these two and then I'm going to put a negative sign in front of the other variables, minus b and minus c. Okay, so if you can do this and multiply it with 1 over determinant of a, you will get your a inverse. Let's do that now. So your a inverse is equal to 1 by determinant of a. Determinant of a is a times d minus b times c. So a times d is 2 times 4 is 8 minus 3 times 1 is 3. then you multiply that with your matrices. So that would be in this case 4, 2, minus 3 and minus 1. So this is nothing but 4 over 5 minus 3 over 5 minus 1 over 5, 2 over 5. So that is your A inverse. The next step, so this is your step 1. The next step, which is step 2, is to multiply your A inverse with B, and that would give your solutions to the equations. So A inverse is 4 over 5 minus 3 over 5 minus 1 over 5, 2 over 5. Okay, you multiply this with your B matrix, which is 10 and 12. Let's solve this equation, or let's solve this matrices. So your matrix multiplication would go like this. So 4 over 5 times 12 plus minus 3 over 5, sorry, I should go back. So 4 over 5 times 10 minus 3 over 5 times 12. Okay, then the second one would be minus 1 over 5 times 10 plus 2 over 5 times 12. So if you solve this, that is 4 over 5 is 40 over 5, minus 3 times 12 is 36, minus 36 over 5, which is 4 over 5. The second one would be minus 10 over 5 plus 24 over 5, that is 14 over 5. So this is actually nothing but your x and y. Let's see if this is what we got. So if you go back to your first traditional way of solving equations, you got y is 14 by 5, which is what you got here. Your x is 4 by 5, which is what you got here as well. So this is a way to solve your linear equations with the use of matrices. So in this video, what you saw is your coefficient matrices are actually inversible. What happens if your coefficient matrix is actually not inversible? So we'll see that in the next video. Thank you.